So we have two triangles, and they tell us information. What other information do you need to apply the specified congruence postulate? So if I wanted to prove that these triangles were congruent by ASA, I would need to know that angle A is equal to angle F. So if they told us that angle A is congruent to angle F, then you could use ASA. If you wanted to prove by SAS, you would need to know that BC is congruent to DE. All right, for SAS, I would need to know that Q equals S. And if I wanted to prove these congruent by SSS, I would need to know that MT is congruent to VD. Now we're going to talk about proofs. Remember, when you're doing a proof, you always put the given first. So whatever they tell you goes at the top. That's the easy part. And all you do for the reason, you just say, hey, you gave that information to me. That's always the first step in the proof. You write down the given. Some people like to spread out the given in between. This is kind of like writing an essay in English. There's sometimes multiple ways to go about the proof, but if we're looking at someone else's proof, then this is their way. You also, kind of like in English class, you put the conclusion last. What are you trying to prove? Well, you're trying to prove that triangle ACD, you're trying to prove that this triangle is congruent to this triangle, BCD. So you're trying to prove that that pink triangle is congruent to the blue triangle. And notice your conclusion always goes last. So if you're filling in a proof, the introduction and conclusion is probably the easiest. Now looking at the rest, we know that AD is congruent to DB. Why? Because they said D is the midpoint. So we know, and it's not just based off the marking because they did this, we know that AD equals DB because if D's in the middle, those have to be the same. So then they drew a line to say that this equals this. Second, we know that angle ADC is a right angle, so then they drew the box. They also know that BDC is a right angle. Okay, how do we know that? Perpendicular lines form right angles. Where did we get that? From here, CD. That's perpendicular to AB, so those have to be 90 degrees. And then they say this angle equals this angle because they're both 90. So now you got your S, now you got your A. And then this is a very, very, very common one. Saying that CD equals CD, if they share the same side, then they're congruent. So we're going to say CD equals CD, and this is one you should definitely remember. Why? Reflexive property. So now you know side equals side, angle equals angle, side equals side. So yes, I could prove these triangles are congruent by the SAS, which is what they put here. And most people will just write AS postulate. So on this problem, we need to fill in the blanks. First thing I would do is just make sure I list out the given. That's always the step one. And order doesn't matter. I'm just going to write it in order. The first thing they tell me is that AC is congruent to BC. Now I would go ahead and make that marking that AC is congruent to BC. How do I know that? They gave me that information. It's a given. They then say that D is the midpoint of AB. In other words, D is in the middle of A and B. So based off that information, I could say that AD is congruent to DB. So then I'd say AD is congruent to DB. Now how did I know that? And there's many ways to write it. I would probably write definition of a midpoint is how I would write it. But you could say that a midpoint shows congruency. I would probably put definition of a midpoint. And then from there, we know nothing about the angles. This could be 90 degrees. We don't know that. But we do know that CD equals CD. So we know that because they share that same side, they must be congruent. So then I could say that CD is congruent to CD. And that is always going to be the reflexive property. So now we got that. And so then we look in our little book of our different theorems. And what happens when you know all the sides, side, side, side? When you have three pairs of congruent sides, you could use the SSS postulate to show congruency, which is what we have. So yes, those triangles, ACD, this one on the left, and BCD, triangle on the right, those are congruent by the SSS. And be careful if you list postulate versus theorem. Notice some of these are postulates, some are theorems. So be careful with that. SSS postulate. So we're given some information, and then we're supposed to prove that triangle DEA, and sometimes I like to see what I'm trying to do. So I'm trying to prove that DEA, which is this one, I'm trying to prove that that's congruent. Especially when there's like multiple triangles on here, I like to mark what I'm looking for. So I'm trying to prove DEA is congruent to FEC. And that helps me a lot. I'm just trying to prove the blue one equals the pink one. So from there, your first step is to write down the given. What is the given? I'll just write it down. AC and DF bisect each other. How do you know that? They told us that. That's the given. Okay. So what does that mean? If you could read my handwriting, I'm sorry. F. I'll just erase that. F. No, at E. That's supposed to be an E. Now where's E? E's right here. So what does it mean that they bisect each other? Well, you have AC and DF. If they're segment bisectors, that means they cut each other in half. So what that means is, I know if AC cuts this in half, this equals this. So I could say that DE equals EF. And you don't really need every single line in here, but I would say DE is congruent to EF. How do I know that? Because it's a segment bisector. Which shows that they're equal, or I could say congruent. And you get that because AC cuts that in half. Well, DF also cuts AC, so this also cuts AC. So now you can say these are congruent. So you know that CE equals EA. And again, that's segment bisectors. To be a segment bisector, it means it's cut in half. And so I have S, I have S, I have S, I have S. I need one more piece of information. And I notice that this angle equals this angle by the vertical angle theorem. So I would say angle DEA is congruent to FEC. How do I know that? Well, those are vertical angles. And then finally, the blue triangle is congruent to the pink triangle. Which theorem or postulate shows that? Well, it would be SAS. And which one is the SAS? SAS is a postulate. So you say SAS postulate.